Hi everyone, it's Mr. Jensen. Today I have a couple things to go over with the weather versus climate notes. So to start, weather is the daily temperature and precipitation that can be even hourly, while climate is over a long period of time, the averages of the averages of the rainfall and precipitation and temperature. So what are the influences of climate? First, you have to start with latitude. So it's kind of simple. If you go towards the equator, 0 degrees latitude, it is going to be the warmest parts of the world. As you go up from the equator into higher latitudes, it's going to be the coldest. And the blue doesn't look too good writing on top of blue. Even if you go south, right? You go south in America, it gets warmer. But as you get to the equator and you start to go south, it will also get colder towards Antarctica. So the further you are away from the equator, the colder your climate is going to be. So equator is the warmest, the poles are the coldest in terms of climate. I gave myself an extra page in case I want to do notes. Insolation. Insolation is a special word. In the notes, you'll read that insolation is 3 different words. Incoming, sol is solar, and then radiation. Incoming solar radiation coming from the sun. And so the reason why latitudes near the equator have such warmer climates is because the insolation that they get from the sun is more direct. So we're a little bit further north than the equator, around like 41 degrees, 42 degrees. And so our area is hit with sunbeams or solar radiation that is on an angle. This causes the sun's rays to be spread out. And when you spread out the sun's rays, it's less efficient energy warming that part of the world. Whereas at the equator, it's head-on 90-degree insolation where it's going to be extra warm. So here's another picture of it as well. This time the sun is on the left side. And I like this one as well because it shows how the angle will spread out. So angle A here is shooting its insolation from the left to the right to the earth. And when it gets there, it's spread out. So you'll see that these rays of insolation get spread out and they cover a large area, whereas the insolation at B makes this smaller area because it's a direct hit onto the earth. So the insolation of Earth is the strongest at the equator and weakest when you get to the very top of Earth. It could also be explained in angles. For example, if I erase some of my drawings, from the Earth's surface to here is going to be a perfect right angle, whereas here you have this angle, and there's another angle. So this one is usually a 90-degree angle. Here they're usually lower. I can't tell you exactly which ones they are, but these are called a lower angle of insolation, and this is a high angle of insolation. All right. So the next one is the proximity to water. I have 2 graphs here. One is Long Beach. The second is Albany. Long Beach is very close to the ocean, as in you can walk to the ocean, and it's also surrounded to the north of Long Beach by the Sound, right? So we have water on both sides, and we have water on both sides of Long Island, so it works for all of Long Island. Then I have Albany. Albany is upstate and is not near any large body of water. So how does that affect your yearly climate or long-term climate? It has to do with these 2 charts. So you'll see that Albany had a high of 30.6 degrees Fahrenheit in January, whereas Long Beach had a 39, right? Albany had a low of 14.5 whereas we only had in Long Beach or Rockville Center might have only had 26-degree low. So the disparities between each day are much different. And then the disparities between, we'll do the highs of each, the highs of Long Beach and the highs of Albany are much different. So if I take the lowest of Albany, which is 30 degrees, we'll round it to 30. And I take the highest of Albany in July, which was 82. And I take my low of 39 from Long Beach, and I take my high of 83. The difference in Long Beach should be less. So Albany has a 52-degree difference. While Long Beach only has a 44-degree difference. The reason being is that water has a high specific heat, and so it helps to keep Long Beach warmer in the winter and Long Island warmer in the winter, and it helps to keep Long Island cooler in the summer. So we have less disparity between the highest of the highs and the lowest of the lows for the year, unlike Albany, which has a higher disparity of highs and lows from the coldest of the cold to the warmest of the warm in Albany. So proximity to water stabilizes or moderates the differences between highs and lows in an area because of high specific heat. It takes a long time for water to heat up, takes a long time for water to cool down. Elevation. So maybe you know this one, and maybe you could just see it straight from this picture. This is Kilimanjaro in Africa, where the bottom is a suitable climate for animals such as zebras. They live in the warm African savannas. But at the top of Mount Kilimanjaro, you'll see that there is, in fact, snow. So elevation causes colder temperatures at the tops of mountains. If you live in a mountainous area, the tops of the mountains will have a colder climate per year or long term, because climate is long term, than their bases or at a lower level. So these zebras are standing in what we would say is probably a warm climate. It's warm down here, but as you hike up, this area of Kilimanjaro is going to have a cold climate based off the yearly averages over a long period of time. So the higher you go, the colder it will be. What else do mountains do? Mountains, we did orographic lifting, but I'll just do it quickly again. Mountains can cause something known as orographic lifting, where if a mountain has some sort of breeze going towards it, it's going to force air to go up. That air is then going to be filled with water vapor most likely, and the water vapor as it goes up cools off. And when water vapor cools off, it turns back into liquids, liquid droplets making clouds. Those clouds will be rainy with a lot of precipitation on what we would call the windward side of the mountain. The air then continues to go on over the mountain, but it's lost all its water vapor, and it's also cooled off because it's high in elevation. So when it's cool, it gets a higher density, and then it will sink on what we would call the leeward side of the mountain. On the leeward side of the mountain, the precipitation has already left the air. The water vapor has left the air. The air is cooled off, so it goes down. But the sand here is hot from the beating sun. So this side of the mountain, the leeward, will be dry and warm. Sometimes the word dry is also used as the word arid. And the windward side will be cool and will be generally like wet, have a lot of rain. All right, then there's land texture. So what do I mean by land texture? Basically, there's only like two extremes. A land texture could be like a dark area. That's what we would consider kind of like a dark forests, like dark green colors. And I did a forest for also rough because the surface of the trees is uneven. So a place like a rainforest where there's a lot of dark greens and then there's a lot of differences in elevation of the trees could be kind of like a dark and rough area. So this is going to absorb insolation. Whereas a light, smooth area, maybe somewhere like Antarctica, the North Pole, light being like the white snow, and then the snow kind of is like a very smooth blanket. This is going to reflect insolation. So if you absorb insolation, it's going to be a warm area, a warmer climate. If you reflect insolation, this is going to be a cooler kind of area. You could think of it as wearing, if it's like July, it's really hot out, and you have like a black t-shirt on, that black t-shirt is going to heat up if you're in the sun. Whereas if you're in July and you're running around and you're wearing like a white t-shirt, the white t-shirt is going to reflect the sun and it'll keep you a little bit cooler for a little bit longer. All right, so that is a crash course in influences of climate. All right, if you have questions, ask me on Google Classroom, read the notes, and there is a climate practice available as a problematic as well. Have a good rest of your day.